Hello everyone, welcome to SCI-EASE. In the last video, I told you about two salts, that is caustic soda and bleaching powder. Now here, in this video, we will do the remaining three salts. Out of that, the first one is baking soda. And it has the chemical name sodium hydrogen carbonate or sodium bicarbonate. And its formula is NaHCO3. You know that in cooking, we use sodium bicarbonate, to make idlis, dosa, cakes, etc. We use this sodium bicarbonate, that is baking soda, so that the pakoras or idlis, vadas, etc. they become soft and fluffy. To explain this, I have made one short in the kitchen series, You can open my playlist and see how it plays a very important role in making idlis and bhaturas. So this sodium bicarbonate, it's also used in the cooking to make it easy so that it can take lesser time. We put it in chanas, to boil chana, we put baking soda sometimes so that it takes lesser time to be cooked. So how this sodium bicarbonate or sodium hydrogen carbonate that can be prepared, that I will tell you. Here the raw material which we are taking is the common salt, that is NaCl, plus ammonia, plus carbon dioxide, plus water. The result is the formation of ammonium chloride. This is ammonium chloride, And the second one is sodium hydrogen carbonate, So the products, they are ammonium chloride and sodium hydrogen carbonate. And we are preparing sodium hydrogen carbonate, This we are preparing. So here the raw materials used, they are common salt, sodium chloride. This means ammonia, carbon dioxide and water. Now when this sodium bicarbonate or sodium hydrogen carbonate that is heated, when we heat it, this will result in the formation of sodium carbonate plus water plus carbon dioxide. And due to this carbon dioxide, the things, they will become soft and fluffy. So you can see my short also on the kitchen series that will really help you to understand this. Now there are many uses of this sodium hydrogen carbonate. First one, for making baking powder. We know one is baking soda and one is baking powder, which is a mixture of baking soda and some edible acid like tartaric acid. So for making baking powder, this is a packed, we get a small box of this baking soda from the market. For making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. This you are to remember. Sometimes this can be asked that what is the difference between baking soda and baking powder. So the answer is with you. Okay, you can tell that baking powder, it has tartaric acid in addition to baking soda. Okay. Now, when baking soda is dissolved in water, what will happen? This will result in the formation of carbon dioxide plus water plus sodium salt of an acid. Okay, and this is this carbon dioxide that will make the thing soft and fluffy. Okay. When I was telling you about the pH, we measured the pH of sodium hydrogen carbonate also. Baking soda, we measure that. It is a mild base. It is a mild base and it is also used as an antacid. This means it is used to neutralize the excess acid which is present, which gives irritation to us in the food pipe. Okay, so this is also used in some of the antacids also, ready-made antacids, and otherwise also we can take a mixture of baking soda, lemon and water and we drink it. That will neutralize the excess acid which is there in a food pipe. So, very important use that it is used as an antacid. Now, the third use of baking soda is it is also used in soda acid fire extinguisher. In fire extinguishers, sodium hydrogen carbonate is used. We open the nozzle and then carbon dioxide that is released, which will extinguish the fire. So this is all about the baking soda. Now the next salt, that is washing soda. Washing soda, its chemical name is sodium carbonate decahydrate. Okay, and its formula is Na2CO3 dot H2O. What do you mean by this dot H2O? This is water of crystallization. The concept I will explain after the preparation and uses of washing soda. Okay. Now, how this washing soda that can be prepared? We know that when we heat baking soda, we get, what we get? Sodium carbonate, carbon dioxide and water. This reaction we have done. Okay. Here we get, what we get? Sodium carbonate. So, I will write the equation again. NaHCO3 when it is heated, sign of heat, okay, triangle, we will get sodium carbonate plus carbon dioxide plus water. Now, when some water that is added to sodium carbonate or it is exposed to air, what will be the result? The result will be sodium carbonate decahydrate, Na2CO3 and 10 water molecules, they will attach to it. When the salt, that is Na2CO3, is exposed to air or some water that is added to it. Okay. What are the uses of this washing soda? From the name itself, it's clear that it must be having some role in washing. Okay. So, one thing is that it is used for removing the permanent hardness of water. Washing soda is used for removing the permanent hardness of water. Sometimes the water is hard. It does not produce leather with soap. So in order to remove this permanent hardness, sodium carbonate that is used. Okay. In all the detergents, there is some percentage of washing soda. This is again another use of washing soda. It is used in the manufacture of sodium compounds such as borax. Okay. And third one is washing soda is used in glass, soap and paper industries. You are to remember 2 uses only. Okay. I have written 3. Out of these 3, you are to remember only the 2. Now come to this water of crystallization. There are many salts like copper sulfate, CuSO4 5H2O, sodium carbonate that is Na2CO3 10H2O, iron sulfate that is FeSO4 7H2O. Then plaster of Paris, which we are going to do after this water of crystallization. I will explain the preparation and uses of plaster of Paris. So CaSO4 half H2O. There are many other salts. Gypsum we will do, that is CaSO4 2H2O, that is gypsum. All these salts, they are the hydrated salts. They are known as the hydrated salts. They have some water molecules attached to it. And the number of the water molecules that is definite for each salt. In some cases, like copper sulfate is blue in color. Okay, this copper sulfate that is blue in color. Okay. For this, we will perform one activity. We will take copper sulfate, which is blue in color in the test tube. Now heat it. What you will observe? That the water molecules, they will stick to the wall of the test tube. And the salt which is left behind, that will change the color from blue to white. Okay? So, when we are taking this copper sulfate, which is blue in color, and when we heat it, just a rough diagram I am making. When we heat it, what will be the result? The water droplets, they will be seen on the inner wall of the test tube. Okay? And the salt, which was blue in color, now it will become white in color. Okay? So, this experiment shows that the water molecules, they have been removed from this copper sulfate, and the salt that has become anhydrous with that salt will be not hydrated, that will be anhydrous without the water molecules, the salt which is left behind, that is white in color. Okay. In iron sulfate 7H2O, that is again green in color. This salt is green in color. Okay. All these salts, they are not colored. Okay. In some of the salts, we can judge the removal of the water of crystallization by the change in the color. But it is not always. Na2CO3 10H2O, when water molecules, they are removed, it will remain white in color or colorless. Okay. Then it's again this calcium sulfate half H2O, that is plaster of Paris, is again white. So, the fourth salt, that is washing soda, which is again a base. Okay, it is again a base and it has many uses in our day-to-day life. Now, the last compound that is plaster of Paris. Okay, and its formula is CaSO4 half H2O. And what is its chemical name? Its chemical name is calcium sulfate hemihydrate. Hemi means half, hydrate. One thing I want to tell you, that for all the compounds you should know the common name. Okay, for 5 compounds you should know the common name, chemical name and the formulae. Sometimes it's asked, okay, so you should know them. That is plaster of Paris is calcium sulfate hemihydrate. How it is obtained? When calcium sulfate dihydrate, which is known as gypsum. It is known as gypsum. When it is heated, calcium sulfate hemihydrate that is formed, and 1.5 water molecules that will be released. Okay? Gypsum, when it is heated, this is heated at the temperature of 373 Kelvin. Okay? And when it is heated at 373 Kelvin, calcium sulfate hemihydrate or plaster of Paris that is obtained. Okay? So, one thing, this reverse reaction that can also take place, that when we add water to plaster of Paris, this will be converted into hard mass gypsum. Why I am telling you that reverse reaction also takes place? Because for supporting the fractured bones in the right position, which is the use of plaster of Paris, doctors have to mix water to this plaster of Paris. प्लास्टर ऑफ पेरिस में पानी मिलाया जाता है और फिर फ्रैक्चर्ड बोन के ऊपर प्लास्टर चढ़ाया जाता है, ताकि जो बोन हिली हुई है उसको ठीक पोजीशन पे रख के ऊपर प्लास्टर चढ़ा दिया जाता है. ओके, सो दिस इज वन ऑफ द यूज ऑफ दिस प्लास्टर ऑफ पेरिस, दैट इज फॉर supporting fractured bones in the right position. Another use of POP, used for making toys, material for decoration, and for making surfaces smooth. And in building houses, the ceiling that is also made up of POP. So with this, our chapter, acids, bases, and salts, we covered a long journey. I discussed with you about acids, bases, salts, pH in everyday life, and then these 5 salts. I have told you their preparation and uses. This is very important. Preparation and use of any salt that can be asked in your exam. So in my next video, I take up some of the questions of this chapter, because in chemistry, sometimes indirect questions, they are asked from each chapter. I will discuss those questions in my next video. Till then, thank you very much.